So the title of the talk is, what does, so what do PhoneGap, Canvas, and Urine have in common? And as you already found out, I mean literally. It's not a metaphor of like what do they have in common. So just a little bit of background. My name is Ian. I'm Twitter, that. And I'm working on a company called Line. And we're building like healthcare apps. So the URL is linehq.com. And we started the company building like tools for people with diabetes to upload data from the devices and share them like kind of like a very private social network where you can learn from other patients and hopefully have a healthier and better life. And that's mainly because me and my co-founder, we have diabetes. And then we started working with another doctor and building this app. So yeah, but diabetes doesn't have much to do with urine. So why I'm talking about this? So basically, there was this thing called Health Hack Day. So it's in Stockholm. They had an event where it was 24 hours to code something like an app doing healthcare. So my sister-in-law is a microbiologist and works at a hospital, and she performs urine analysis on patients. And one of the things she said is like, first of all, like we don't have enough data. Like you come in, we get one sample, and then based on that sample, we give you a diagnosis. And second of all, just to show you what the urinalysis is, if you know the things they use is, so these are the strips you can buy like commercially. You can buy them yourself in a pharmacy if you ask. They might not have them in store, but they will give them to you because you don't need a prescription for it. And your doctor might ask you to take tests at home if you have some kind of urine infection or kidney infection or different conditions that they might want you to monitor at home. So this involves dipping and steeping urine, looking at colors changing over time. So the stick, it has a lot of reagents, and those reagents, they need to be measured over time. So the first two needs to be taken at 30 seconds, the other two needs to be taken at 45, the other five at 60, and the last one at 2 minutes. So you need to handle urine, you need to have a timer, you need to compare colors, you need to map colors to values. It's pretty daunting. So I think I could build in 24 hours an app that does image processing using the camera and does the thing for you. And I looked around and I was thinking of going native, like augmented reality thing. That looked like it would have taken too long. We looked at Accelerator, Clutch.io, like all other options, and we ended up going PhoneGap, of course, because I had used PhoneGap before, but I didn't think it would work, and we tried it, and it worked really well. So we used the only API we use from PhoneGap is what is it? Camera.getImage, I think it's called, and that gives you a base64 string of the image, and then we load that into Canvas and we do image processing. But I want to show you the app. So I'm actually I took a urine sample in the morning. It's here. I hope nobody drank the coffee cup. If you did, please go out and. So yeah, no, I try to hide it. I tried. Some people really like coffee. So this is what you need to do. I actually can show you. So most people actually don't know what they have to do, so they have to read a manual. So we put a manual into the app. I just need to, it's good. Yeah, there we are. So this is the app. It's all web. So you have a tutorial. And yeah. You figure that out yourself, I think. So if you excuse me a second, I'll just step on. Okay, done? No. Okay. Last time I demoed the app, I actually had somebody from the audience give me a sample. Like really, he was heading to the bathroom. So you dip the stick in the urine. You'd have to dip it for 2 seconds and then take it out. Like you shouldn't do more than that. So it's tricky. And then you start a timer. That's like you start the app. You put the thing on the mat. So we build a little mat. I'm going to talk about why we build the mat later. Then it takes pictures at different time intervals. And it gives you results. It's a bit lagging because it's working over AirPlay. So the cool thing is, obviously, this is a phone, and it has internet and it has a great camera, so you can store stuff in a database and pull it off. And so what you can do is, unlike with other things, you can actually record the results over time and then see what they mean. So here are some readings I took. So I have, this is basically the same view as a strip. You see the colors that you actually got and the values you got. But for most people, this doesn't mean anything. I've learned more what these things mean, so it's meaningful for me. But obviously, if I click, then I get a description, I understand what it means, and can have a conversation with my doctor about it. So it's not just a number anymore. So let's show the app. So basically, now I'm gonna start. So I need to first, I have a little napkin in my pocket. So don't shake my hands after this, please. So yeah, dipping, 2 seconds. I take it out, and I start the timer. I place it in the mat, and it sees, oh. But it still works. Okay, the camera came up. Take a picture. Can you see in the screen what's happening? Okay. Great. So there I did the image processing. It's matching all the colors. And now it's going on to the second picture. I don't know if you saw this, but so it counts down for every set of biomarkers. So then we go again. I'm not going to do the entire thing, but just so you get an idea. Yeah, it kind of matched. And again, it goes like that. So it's looking pretty good. I don't have any glucose in the blood. I don't have ketones in the urine, sorry, no bilirubin. I'm going to do a last one, and then I can go to the demo, to the coding. Yeah, so this is a problem, and you see like the image is rotated because the device is rotated. So this is actually, I would like to mention that this actually breaks. So when you get a callback in the API they provide, they don't give you any EXIF data. So all images, they have EXIF data, so location, orientation, camera type, and stuff. So it would be really nice for people at PhoneGap if you could add a callback with EXIF data, so I know the orientation of the image and I can rotate it. Because right now I don't know what orientation it is. I have to assume that it's portrait, and it's not. Awesome. Thanks. I'll just shut this off. So that's the app, and as I said, we built it for the competition. We ended up winning, and the cool thing is that I would have never been able to do this in 24 hours. Wasn't it for PhoneGap? It's just like I don't code native Objective-C. I'll do now, but at the moment I didn't, and that's in July. So I'm not, even if I did, I wouldn't be capable of doing it. I know some image processing. I did this with a friend who's really good at image processing, and I work a lot with web. So actually doing it in PhoneGap was really straightforward. We actually had time to sleep that day. So it turned out pretty good. So we won the competition, and we got contacted by a hospital who actually wants to start testing it, and it's like the biggest hospital in Sweden and the biggest hospital in Europe. They want to start testing it in clinics and in Africa and also in homes in Sweden. So it's pretty cool to have like a clinical app that replaces a medical device. So we've tested it and it works just as well as the medical device. So it's a medical device that actually performs this function. It doesn't have internet, it doesn't have a color screen, it doesn't store things in the database, it doesn't explain new things. It just prints a little bit of paper and it costs more than an iPhone. So we're getting a really, really good feedback, and just like you say, we wouldn't have been able to like iterate it so fast without PhoneGap. So yeah. So what I want to do now for the rest of the talk, I'm gonna get my glasses so I can code. I mean, I thought about showing like what I did in PhoneGap, but the actual PhoneGap part of it is pretty standard. It's just an app in PhoneGap, and it's just calling a camera. So instead, I thought I'd show the actual like image processing. So when we were developing, we had one guy doing the image processing. Let me actually just show the faces of the people who were part of the team. So it was us three. That's the picture I took after. So one guy doing the image processing in the browser, two other guys, and then two other guys doing like server and UI, and we were all working on the browser. Like we packaged everything in PhoneGap at the end. Like we didn't even touch PhoneGap because we knew like it would work. So yep, I'm gonna just show you some demos of things. I'm using a little library that I built for running code. So if you know JSPin, you've used JSPin? No? Yeah? Yay, JSPin is awesome. So JSPin is great, but it runs locally. It runs in the cloud, and now it runs locally also. So what I did is it's a little script that runs a directory and then listens to the changes, and then refreshes the page every time you make a change in the directory. So just so you see that the demo, why things are happening. So if I put in some code, and I save, then it refreshes the page. And if I do that for some of the dependencies, so this file depends on match, and I save, it also refreshes. So when I save, you're gonna see the screen refreshing. So how much time do I have?
10 minutes.
Okay, good. So first of all, like a lot of people ask us, why don't just take a picture of the strip? These classes. Why not just take a picture of the strip and then not without having to have the reference thing? First of all, because we needed to do it in 24 hours, so it had to be fast. But afterwards, we figured out that we had a lot of advantages. So an approach to doing image processing, you know the strip is white. White balancing is a really good way to correct an image and know that you get things all along and you can actually match colors. But it was pretty hard to find the strip within the picture. You have a little thing in the bottom. You can make a QR code that you could position, but it would have taken time. So what we did instead is we put the actual sticker that sticks in the box, which is the one you actually have to use to compare colors. We put it in the image. So first we white balance the entire image because we know some certain areas are white. And then we basically match colors in the board. So we don't compare against colors in like somewhere else. We compare the colors in the picture you just took. And that gave us really good results, not only because we actually saved each image so we can compare the result we took against the result our eyes would make and the result the machine would make. So every time you take an image, it's saved, and the results are saved. And yeah, and the other thing is it made it easier to compare the colors. So now I'm gonna do a bit. I didn't have time to like code some of the part through, so I'm gonna paste in code and show you like the approach we took. So if you have this, like how do you find, like first, you don't know like the image, the size of the image. It could be here or it could be here, so you can't rely on dimensions. You can rely on proportions, but the first thing you need to do is you need to figure out where the strip is. But the cool thing is we know we know this, so we can do some assumptions. And so what we first do is we need to find the bounds of the strip. So we start at the middle, and we take the middle of the image, and we assume that you actually took a picture in the middle, and then we take a point up. So we a point here, a point here, a point here, and a point here, and then we use this library called Pixel.js, which my friend Marcin he created. That has a lot of functions to white balance images and get color averages for a region and find the first white pixel in a row. So what we do is we navigate from the top of the image down until we find the first white pixel. And we do that for all edges. And there's so I can show you the code for that. So that would be in match. Can you see the code? Yeah, you can see it. So here we found the bounds. Obviously, you're not going to be able to go through the entire code, but it gives you an idea of. Actually, it's pretty simple. So we're taking all the positions and we're saying pixel.walk till white, and we're saying start at give it the pixels, start at the middle, top, and then go down, and then it gives us the coordinate of the first pixel, and we do that for all the edges. And one thing we have to do because of a hack. So if you notice, the right corner there is not straight. So what you do there is we get like a bunch of points, and then we average them to get more or less aligned. So that's why you see in the code here, the right position is being taken 3 times, and then we get the average to get the best coordinate. So yeah, so if I just want to paste that in so you can see how it looks like. Yeah, that's a good question. So the first thing, so here we have a canvas. What we're doing is Canvify image is just loading the image into, we have an image tag and we have a canvas. So Canvify image is just a little function that takes the image, loads it into canvas, gets the pixels, and then you can work with the pixels. And the first thing we do after that is we white balance the image, and then we assume white. So we have white. So we have the pixel.js has an automatic white balancing, and then we know certain points are white, so we get the white. So you can ask questions as we go along. Okay, so I'm going to go fast now. So first we find the bounds of the image. So we have an object that returns. We see bottom, and we have all the coordinates of bounds of the image. So this gives us, so if we draw that, that gives us those lines there. I don't know if you see them. They go up and they define like the bounding box of what are we looking at. So once we have that, then we need to actually find each biomarker. So those strips of colors, they all have the different biomarkers. So we need to define like where they are placed. And here is where we do a bit of, we don't know the exact size of this because it depends on how you take the picture. So we work with dimensions. So like proportional, this is proportionally 2 times longer than that. So we do that. And I have this function, I'm just going to paste it in, that basically finds all of the biomarker strips and then draws the boxes. So it kind of bounds them. As you see, it's not perfect. And it can be perfect. It was done in 24 hours. So this function does 2 things. It gives you like all the biomarkers, the position of the strips, and then it finds the color. So the color mask. So like as I said, we're getting the color from the image. So you can see this has an array of colors. So it tells you this coordinate, this is the color. So I will, if you come afterwards, I'll show you this library, Pixel.js. Pixel.js has like a nice color average thing. So we're not taking the color of a pixel, we're averaging around an area. So that's how we get the color for each of these. So like we navigate, we know the bounding box of this, we navigate, we get the color average, then we continue to the next one, we get the color average, and that's how we pick the colors. So what we do next is that we actually need to find the strip itself and find the markers. I'm almost done. So now we find the markers. Again, I mean, everything is relative to everything else. So if you look at the code, it's just a lot of math and moving pixels around and moving left and right. And it positions all of the elements. We found all of the biomarkers in the actual strip. So the only thing that's left is actually to compare. So we get the matches. If you come later, I can like share the code and we can go through more deeply. So now what I do is, yeah, basically we compare the colors and we find the one that most closely correlated. And this is also a fun part. Like we never thought about this would be an issue, but like how do you compare colors? Like it's not that easy to compare colors. You have RGB, it's in 3 different spaces, so you can take RGB and put it in, compute the RGB like into a function that then you can like put in a 2D space and then measure distance of RGB. But what we found out is like if we measured the RGB value of colors and compare, then we didn't get good results. There's a lot of ways to show colors. Like you can show colors in RGB, HSV, and there's a lot of other color transforms. So what he ended up doing was a pretty cool hack. I'm basically done. Yeah, no, you got 3 minutes. Okay, cool. So we made like a democratic approach where we took like 3 different color spaces. So we took HSV, RGB, and another one called HCL or Chroma. So for this, we used a library called Chroma.js. It's available in GitHub, and that we compute the score for all of the values, and then we get the one that is most correlated. So for this, I'm going to paste in the last the last piece of code. Yeah, so if you see here, if you see this, like each of, so these are the colors we picked based on the script. Oh, this is pretty pixelated. Move a bit out. So you see the little edges there? Those are actually the color, the scores of each different color of each different space. So when you see in here we have complete agreement. They all agree that is this. And here we have two spaces agree that is this and that. And here we have different spaces. So what, and we didn't know that what would work and what didn't, but we found by doing this we actually got really good results, and we are getting as good results as the machines are getting, so as professional machines. And here, for example, this case is funny where you have 3 different colors. There's no agreement. We take the strongest value there. And as you can see, like, you can't really tell yourself what is which. So it's as good as at least the human eye and also the machine. And as I said, it's all JavaScript. It's all made in PhoneGap. We use a single call from PhoneGap, and it's a medical device in a way. So yeah, I think that's it.